Hey guys, so in this video I'm going to talk about how to find CL from CP. So basically, the second part of the project asks you to find CL, right, from integrating the CP. So I had a lot of questions about how to do that. So I'm here, I created this video, post this in this video so that, you can watch. So basically, in order to find CL, you need to find CP first, right, from XFLR5. So here, I already have this here, but in order to do this, you can go to NACA files, 20012 or just 12, then click OK. And I'm just going to replace the existing file here. So you see here, you see the airfoil, and then in order to do the analysis, go to analysis, click define analysis, and make sure to insert the Reynolds number that you calculated, and then click OK. All right, and then make sure to click sequence in this box so that you can change the angle of attack from 0 to 10 in increments of either 0.5 or 1 or 2. I'll leave it up to you. All right, and then click analyze. So the program will do the analysis and then it will show you CP distribution. Make sure you click this graph, okay? And so basically it will show you CP distribution for all angles of attack. So just pick one angle of attack. I think it's in the handout I mentioned 4 degrees. So let's do 4 degrees. I'm going to click right click. Here it is current OP point. I'm going to export. And then, so I'm just going to save it as a .csv file. You can save it either as a text file or .csv. I'm just going to save it as .csv because you can open in Excel. And then click save. I already have file name. With that, I'm just going to replace it. All right. So when you open that file in Excel, this is what it'll look like. You have 4 columns. You have X, CPI. CPI is inviscid and CPV is viscous. Okay, so you can take either one of the two CP distribution. Just for now we just go with the CP inviscid. Right now, since it was exported directly from XFLR5, this will be in text format, not in data format. So what I'm going to do is click the first column in Excel and go to data and do text to columns, click delimited, click next. So you can see that the values are separated by space. So I'm just going to click space, next, click next, and there you go. So now you have separated the data. So this is like X. Here you have CP inviscid and CP viscous. We don't have to worry about these two columns right here. So if you plot the first two columns, which is the X and CP, you get a graph like this. Now this is basically the graph which you saw in Excel, right? So in order to find CL, you need to find the difference between CP upper and CP lower, right? That's the formula for CL, right? So the formula for CL is, CL equals, I don't know if you can see, you can integrate. So basically CP lower minus CP upper. Oh, hold on. CP upper times the X, right? So basically this is the formula for CL, right? So in order to do this, you need to find this difference between CP lower and CP upper, which means you need to find the difference between CP lower, which is here, the positive axis, and the CP upper, which is on the negative axis, right? In order to do that, you need to separate CP lower and CP upper first. Okay, let's try do that. Let's try doing that. All right. Now, 0 to 1. Here the chord stops, or starts. So I'm just going to click the data from this point, cut it, and then put it in the next sheet right here. Okay. Again, you will see the reason why we have to do this. Now, I'm going to make this, so this goes from 1 to 0. What I'm going to do is I'm going to make this go from 0 to 1 as well. So when you go to Excel, there is a command or there is a function. Here, data. So basically you can sort your numbers from either ascending order or descending order. So I want to go from 0 to 1, so I'm just going to go from lowest to highest. If I click this, you'll say expand the select. It will ask whether you want to expand the selection or just the column. I'm just going to expand the entire selection and then do sort. Okay. So now what you see here is that you have switched. Instead of going from 0 to 1, you actually went from 1, or instead of going from 1 to 0, you actually went from 0 to 1. So I'm just going to select the first two columns, cut or copy it, go to the sheet where I have this, and then I'm going to paste it again. All right. So basically, we have two columns, and we need to find out which one corresponds to upper surface and which one corresponds to lower surface, right? So in order to do that, we can actually plot it. Now let's plot. Oh. So we can select this entire column. Let's plot it. So it looks like this is a CP of the lower surface because it's in the positive axis, right? I'm going to add the negative axis too in a minute here. So go to add and click this data point, and then I'm going to plot the CP as well. Okay. So when you click this, here you go, right? Now we have a 0 missing. So I'm just going to lower this down. So basically you can create this as a negative, right? So when you do that, extend this so that you close the loop, okay? So there it is, right? So you have the CP distribution on the upper surface, CP distribution on the lower surface. Now, according to the formula, you have to subtract the upper from the lower, right? So here, I'm just going to do CP lower minus CP upper, right? So we know the lower surface is right here, and the upper surface is right here, right? So equals, so CP lower minus CP upper. Click enter, and then you can just drag it, right? All right, so now let's plot this variation, see how it looks like. Right, so we can double click it or delete it, click this line, just transfer it over here. All right, so here's what you have, right? Here you have the variation of the difference between CP and CL. So basically your coefficient of lift is nothing but the area under this curve, right? So in order to find area under this curve, you can use an integration function called trapezoidal integration. So what I'm going to do now is I'm going to post this numerical integration function, this spreadsheet in Isidore, which you can download. Okay. Now all you have to do now is select the here, let's say it's here, right? So select the first column, all right, copy and paste it in here. All right, now go back, select the difference between CP and CL. Oh, go to this integration Excel sheet and then paste it. Oh, paste it as a number, right? There it is. So basically you see this variation like we had in our graph, right? Now make sure when you click this variation, okay, so click the last data point here and double click it. Okay, when you double click it, you can actually see that the final value, let's do this as well. So here you have the numerical integration value, here you have true, and you have the error. Okay, so this type of integration is called trapezoidal integration. So basically the value you get in the end, this value right here, is the area under the curve. Okay, now let's compare the value. Basically, so this is our CL, guys. This is our CL that we need, okay? Now let's compare this to CL we got. So we got around 0.44. Here you have 0.5. It's pretty close, but you got to note that this CL is for the viscous CL, not the inviscid CL, okay? So, there'll be a little bit of difference, but you'll be in the same order of magnitude, okay? So you have around 0.536 at 4 degrees, right? So basically, this is what you need. Now, all you have to show is show this graph, right, where it is. So in your report, what you can do is show this graph right here, and then make sure to state what the area under the curve is. You can state that you found the area under the curve using trapezoidal integration using this Excel sheet. Okay. All right. Hope that helps, guys. Sorry this comes late. So if you're not able to do this before tonight 11, that's we'll think about extending the due date for the project. Okay, but make sure to turn in the portfolio by midnight tonight. All right. Hope you guys had a good weekend. We'll see you on Tuesday. All right. Bye, guys.